Today we're going to be looking at dividing radical expressions. There are a lot of steps on your notes, but for the most part, these are kind of like when you're looking to simplify like a fraction or combine like terms. A lot of these steps are going to be almost common sense things. The list is just sometimes you use one of the rules, sometimes you don't. What I'm going to do is just kind of jump into the problem and explain what I'm doing, because if I go through and read these steps to you, it's really not going to make sense until you see a problem. This first example, divide, it says reduce if both numbers are under the radical or both not under radical. If you look in the top corner, if you see one large radical symbol with a fraction inside, you can think about that as each number being inside its own radical. This is similar to when we did like adding and subtracting. We combine things and simplify things that are both inside or both outside. So because this is one fraction underneath this radical symbol, I can reduce this by just dividing 32 by 2. If I do that, I get radical 16 over 1, or just radical 16. And both of these end up with being perfect squares. If you notice, that's one of our next one. Check for perfect squares under the radical. This would become radical 4 over 1. Technically, 1 is a perfect square because 1 times 1 makes 1. Or you could write your answer as just 4. If you were to, in your calculator, hit the radical symbol and then in parentheses put 32 divided by 2, you would still get whole number 4 as your answer. This next one, B. 2 and 3 are both outside the radical symbol, but 2 and 3 don't simplify, so I'm going to leave them the way that they are. 18 and 24 are both inside the radical symbol, so if they have something in common, I can divide them by the same thing. I can divide both of these numbers by 6. By doing this now, it saves me from working with larger numbers later. That 2 and 3 are going to stay 2 and 3. But now this is going to become radical 3 and radical 4. Radical 3 I can't do anything with. Radical 4, though, is 2 times 2, which is a perfect square. So I can change this to just be 2 radical 3 over, this would just become 2. 3 times 2 makes 6. And before I write my final answer, I can simplify things that are either both outside or both inside. Because 2 and 6 are both outside the radical, I can divide both of these by 2. If this was radical 6, I could maybe do something with the radical 3 and radical 6, but I can't because they're not both under a radical symbol. My final answer here would be 1 radical 3 over 3, because the 2 over 6 simplifies, or just radical 3 over 3. That 1 in front really doesn't mean anything. It's kind of like having 1x. Next one, this one says rationalize. This problem, if you notice, I can't simplify 10 and 3, like I did 32 over 2. I also can't simplify them like 18 and 24. So all I do for this problem is I want to, right here, if the radical is in the denominator, rationalize by multiplying the numerator and denominator by the same radical. All that means is I want to think about this problem. I want to change it following this step up here. I would think about this as radical 10 over radical 3. And what I'm trying to do is just not have a radical symbol in the denominator anymore. So what I do is I multiply the top and bottom by my denominator. So I multiply by radical 3. When I do that, I can multiply these together because they're both inside a radical. I get radical 30. And then underneath I would get radical 9 because 3 times 3 makes 9. From there, I can simplify this to radical 30 over 3 because 9 is a perfect square. The goal of rationalizing is to just make sure that your denominator is a whole number. So what we do is we increase the size of the numerator by multiplying so that we can divide by a nice whole number. That way we're not dividing an irrational number by an irrational number. Next one, D. I can divide both of these by 3 because they're both inside the radical symbol. So divide by 3, divide by 3. This would become radical 2 over radical 11. I can't simplify those any farther. Neither one of these have any perfect squares in them. I'm now in a similar problem like I was over here. I need to rationalize this. I don't want a radical symbol in the denominator. So what I want to do is multiply the top and bottom by radical 11. So I would get radical 22 over, and technically there's a pattern here. This just means get rid of the radical symbol and it just stays 11. My goal, like I said, is to just make sure I don't have a radical symbol in the denominator anymore. That's the goal of these. Next one, 2 over 10. I can simplify these by dividing them both by 2, so that would become radical 1 over 5. And I want to think about this as radical 1 over radical 5. Multiply them by radical 5, top and bottom, and I'm going to get radical 5 over a regular 5. Just keep in mind the goal is to get rid of a radical in the denominator. Next one, letter F. I can't simplify 9 and 5, but I can simplify 18 and 27. Both of those can be divided by 9. Remember, I'm only dividing what's inside the radical symbol. That's going to make 9 radical 2 over 5 radical 3. Similar to the last two problems, I need to multiply the bottom by that radical 3. The only thing that's going to look a little bit different when I do this is I have a whole number 5 here. Top's going to be easier to figure out. 2 times 3 is going to make 9 radical 6. That's not going to change because I can't break 6 down any farther. This is going to be over 5 times 3 because this just means get rid of the radical symbol. So I'm going to get 9 radical 6 over 15. I can simplify the 9 and the 15 because they're both outside the radical symbol. I'm going to leave this as radical 6. So my final answer here is when I simplify 9 over 15, I get 3 radical 6 over whole number 5. And I found my goal, which is not having a radical in the denominator anymore. Last problem. Move this bit. I don't want to have a radical in the denominator, so all I want to do is multiply both of these by the radical 3. Like this. When I do that, I get 6 radical 3 over 3. I can simplify this 6 and this 3 and get whole number 2 radical 3. You could also think about this as 2 radical 3 over 1, but you can just think about it as the whole number. Kind of like how you can think about like x is also 1x to the first over 1 if you really want to make it fancy. I've crossed off this problem with the variable because we're not going to use variables for this chapter for the multiplying and dividing. What I want to show you though is you might get a problem on your homework that looks something like this. If you see something like this, notice how both of those are perfect squares. You can, instead of multiplying the top and bottom by radical 25, pay attention to looking for perfect squares right away. This kind of problem is just going to simplify to be 4 over 5, and you're going to be done. Sometimes you'll have a perfect square number sitting right in the middle of the problem right away. Make sure you simplify that first because it eliminates a radical that you have to work with later on, and it's going to get rid of a lot of trouble you might come across.